Statistics 3, confidence interval for a mean. So type 1, calculating the 95% confidence interval. So here we have a certain type of tennis ball is known to have a height of bounce which is normally distributed. And if it's normally distributed, then we know that we can apply our central limit theorem. And it has a standard deviation of 2 centimetres. So we have a sample of 60 such tennis balls. So that's our sample and our standard deviation. And we're told that the mean height of the bounce of the sample is 140 centimetres. So the first thing we want to do is find the 95% confidence interval for the mean height. Okay, so what is our 95% confidence interval for the mean? Well, it's the sample mean plus or minus the margin of error. So what we want to do is write down what is it that we're actually given before we use the formula. So if we look, we have our standard deviation is 2 centimetres. Our sample size is 60. And our sample mean is 140 centimetres. So if we put that into our formula then, what we have is our sample mean minus 1.96 times the standard deviation over the square root of 60 must be less than or equal to the mean, as the true population mean, which is less than or equal to the sample mean plus the margin of error over root 60. Okay, so if I sub that in to my calculator, then what that leaves me with is 139.494 less than or equal to the true population mean, less than or equal to 140.506. So what does that actually mean? Well, it means that the true population must lie within the confidence interval of 139.494, and that would be in centimetres, to 140.506 centimetres. So in other words, we expect the true population mean to lie within these two values of our tennis balls. So in other words, if we were to drop them, we would expect the height of the bounce to be somewhere between 139.494 centimetres and 140.506 centimetres. In other words, we're at 95% confident that the true population mean lies between these two values. So in other words, that the true height of the bounce is somewhere between these two values. So part 2 says then explain what is meant by a 95% confidence interval in general. So we say a 95% confidence interval means that on 95 occasions out of 100, the interval will contain the true population mean. Okay, and then part 3, we go back, says if a tennis ball is selected at random, what's the probability that its bounce lies outside the confidence interval found? Well, we're 95% confident that the true population mean, in other words, that the height of the bounce is somewhere between our two values of 139 to 140, but therefore outside of that interval must be the remainder, in other words, 5%. So the probability that the ball lies outside the 95% confidence interval is obviously 5%, in other words, 0.05. Okay.